Good afternoon, everybody. Today we are going to discuss about convolution codes. Convolution codes are codes that depends on present input values and also the values that we have in the next state. So here we are using shift registers, registers which are memory elements that are used for storing data. So let us discuss about convolution codes in this class today. So here, in convolution codes, we are using shift registers. Let us consider only three shift registers for a better understanding. M0, M1, and two other three shift registers, which are used to store the input bits. The first M0 register is used for getting the input bits. So the message bits are input to the M1 register. Then, in the next clockwise, this content of M1 is shifted to M1. The content of M1 register is moved to M2. Whatever was present in M2 register will be discarded. So this is how the data is moved from one shift register to the other. M0 is the register which takes in the input bits. M1 and M2 represent the next state of the registers. Now, we take an output x1 by taking connection from M0, M1, and M2. And output x2 is taken from M0 and M2. We do an XOR operation to get XOR output of M0, M1, and M2 registers. X2 is the output of M0 and M2 register with an XOR operation. And the final output X is switching between x1, x2, x1, x2. It goes down. Now, let us see with an example of an input with 110 given to the shift registers, and we will see how we can construct a code tree and trace code to this example. Now, as I told you, M1 and M2 are the two registers which represent the next state. So this is the state for the M1 and M2 registers. Represent the next state. So if the contents of registers M1 and M2 are 00 with the state A, 01 is state B, 10 is state C, 11 is state D. So having an understanding of how the registers operate and what are the different states for the contents of M1 and M2 register, let us start designing a code tree. So we have having the input bits 1, 1, 0. During the initial stage, all shift registers contents are 0, 0, 0. During the first pulse, bit 1 enters, this is M0, M1, and 2. During the first pulse, bit 1 goes to M1 register. The contents of M0 is going to be M1. Contents of M1 register is going to be M2. Okay. So now, what is the output X1? X1, I told you, it is M0 XOR M1 XOR M2, which is 1. And output of X2 is M0 XOR M2, which is also 1. Okay, so output X1, X2 is 1, 1 here. And the state depends upon content of registers M1 and 2. Here the state content of register is 0, 0, so state is A. Next, during the next clock pulse, the next input bit starts with. So here in M0, we have the next input 1. This content which is already present in M0 is shifted to M1. Content of M1 is moved to M2. So now X1 is M0 XOR M1 XOR M2. So 1 and 1 is 0. 0 and 0 is 0. X2 is M0 XOR M2, which is 1. So output is X1, X2 is 0, 1. And let us see the state. State is 1, 0. So state, the state of content of M1 M2 is 1, 0 is state C. And now let us come to the last LSB bit. During the next clock pulse, 0 bit moves to M0. Whatever was present in M1 is shifted to M0 is shifted to M1. M1 is shifted to M2. Now X1 is 0 XOR 1 is 1. 1 XOR 1 is 0. X2 is M0 XOR M2, which is 1. So X1, X2 is 0, 1. And the state is 0. Now, in order to draw the code tree, let us have in mind that if the input is one, we go down. If input rate is 0, we go up. So, based on this understanding, let us draw the code tree. So now we are in state A, and the input bit is 1. So we go down. Okay, we are in state A. Input bit is 1. We go down, and then the output here is 1, 1. Now we are in state C. Here again the input bit is 1, so we go down, and the output here is 0, 1. Now we are in state B. The input bit here is 0, so we go up. Okay, and now see here the last clock pulse, there are no inputs to M0. So M0 becomes empty. Whatever was here, M0 moves to M1. Content of M1 is moved to M2. Now the state is P. So we are in state P now. Okay, and the output here is 0. Okay, so this is how we draw the proportion. Now, based on this knowledge, we will draw 4 threads. Trellis code is again a very important concept which we have to understand. Now, we will go in for the trellis. This table, which is very, very important before we draw the trellis code. So here, M0, M1, M2. X1, X2, current state, next state. This is the current state. And this is next state. So here, we can have the input bits to be either 0 or 1. So let us consider all both conditions for the various states. Now, the current state is A. The next state depends upon M0 and M2. M0 and M2, which is also A. Here, current state is A again. Next state is depending upon conditions of M0 and M2, which is 1, 0. 1, 0 is C. This is state B. The next state is 0, 1, which is here again. This is next state is D. 1, 1 is D. 0, 0 is A. 1, 0 is C. 0, 1 is B. 1, 1 is B. Now let us find the outputs. Here it is 0. Here it is 1. 1. X1 is nothing but XOR of M0, M1, and M2. So based on that, it's 1, 0, 0, 1. X2 is M0 XOR M2, which is 0, 1, 1, 0, 0, 1. Now, based on this, we will now go to draw the trellis code. Before drawing trellis code, we have to keep this in mind. The dashed line represents input bit 0. Sorry, the solid line represents input bit 0. The dashed line represents input bits 1. So we have 4 states A, B, C, and D. Where the input bit is 0, this is current state is A, the next state is also A, and we get it out as 0, 0. When it is in current state A and the input bit is 1, it goes to C, which we represent by dashed line, and we have the output as 1, 1. Current state is B, the next state is also B, when the input bit is 0. The output is 1, 1. Current state is B. The next state is B when the input bit is 1. The output is 0, 0. Current state is C. The next state is A. And the input is 0 and the output is 1, 0. Current state is C. The next state goes to C again. And the input is 1. The output here is 0, 1. Current state is B. Next state is B, that the input is 0. The output here is 0, 1. Current state is B. Next state is B again. The output is 1, 0. So this is how we draw the state. Thank you.